Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2017, time zone 2 in May, question number 22, asking a really fundamental stuff about topic 7, equilibrium. Let's see, which variable affects the value of the equilibrium constant Kc? Although you may see, oh, such an easy question, how come it is kind of worth mentioning? Is because still I know quite of a bunch of students do not really understand the difference between equilibrium constant and another concept. Remember, that is going to be equilibrium position. Equilibrium position. So remind you that equilibrium position and equilibrium constant are two individual concepts. They are actually having different factors that being affecting. First of all, equilibrium position is talking about the majority of the particles or molecules at the end after the reaction, that whether they lie on the right hand side or left hand side. So this is going to be a qualitative description, no numbers, but just you talk about the left hand side or right hand side for the majority of the molecules. That is going to be equilibrium position. So that is a qualitative description. But equilibrium constant, which is going to be much more quantitative, description that's showing the exact ratio of the products and reactants. So one side is going to be a rough description. One side there's going to be a much more solid, specific mathematical expression. Although the function of the equilibrium constant is still helping us to understand the equilibrium position, but remember they are subjecting to different factors. All in all, normally we describe majorly three factors that we need to consider. The first one is concentration. The next one, which is going to be pressure. And finally, that is going to be temperature. These three factors are really famous in terms of the concept in topic 7. But remember, if I cut it in this way, cut it open, right, like this, right? The left side I put the equilibrium position, and the right side I put equilibrium constant. So that is Kc, right? K with a subscript C here. Let's make it more space, right? So remember, all concentrations, pressure, and temperature can affect the equilibrium position of a certain equilibrium. That means the majority of the particles can now move more to the left or more to the right. So the position of equilibrium can shift to the left-hand side or more to right-hand side respectively. But for equilibrium constant, remember only one factor, temperature, that can affect its overall value or the ratio, but not for pressure, not for concentration, right? So obviously you are not going to understand the reason behind, as the explanation can be a bit more complicated. But roughly speaking, what students must be able to know is that equilibrium position is a much more qualitative description, roughly describing the majority of the particles, whether you are on the right or on the left hand side within an equilibrium reaction or reaction under the consideration of equilibrium when the system has reached the equilibrium position, right? But equilibrium constant is a much more mathematical, quantitative expression directly showing the ratios of the concentrations of products over reactants when the system has reached equilibrium. So that is more specific, right? So when the numbers is really specific, it only subjected to one factor to change, so that is temperature. But equilibrium position is easily fluctuated, as we have learned it from the Le Chatelier's principle, a really famous theory or principle that explaining how the system will respond when we suddenly change the system's concentration, pressure, or temperature. All these will lead to the changing of the equilibrium position, right? So that's why, all in all speaking, if they're asking for the factor affecting the Kc value, only we choose D, right? But for atmospheric pressure or the concentration, these two only affect the equilibrium position, but not the equilibrium constant's value, right? And also remind you that catalysts never affect anything about equilibrium, no matter the equilibrium position or the equilibrium constant. So if you put it at the end, catalyst, it has both no effect on position and no effect on Kc. What catalyst really affecting is only the rate of the reaction, which simply means you can faster to achieve the same equilibrium position and achieve at the end the same ratio, the same Kc value, but just using a shorter time frame, but you never affect the position of equilibrium. That means the majority, you know, not affecting it, and also the value of the Kc, you're not going to change it. So that's why always not anything about catalyst, right? So that's why for this question, answer simply goes to D. But the concept related is a really big issue, that to be able to understand the difference between equilibrium position, a qualitative description, and also the equilibrium constant, a quantitative description.